So what tools do we have with lighting? So this is the first piece of how we read codes. First is going to be a ring light. Has anybody ever used a ring light, even if it's not in a barcode reading application, maybe with home photography? This is going to be your usually lowest cost type of light, meant to give you as close to a representation of the light coming directly from the camera as you could assume. Obviously, it's not directly in front of the camera because the camera is in the way of where those lights are, but this is going to be when you have fixed mount types of readers. And I can pass one of these around here. I know you've never seen one of these before, but you can see the lights, while that's all part of the actual camera, that would be the same configuration as a ring light. It's around the actual optics. So thinking of that, anything that this might cause as a problem. Having that light being, just right there on either side of the actual imaging, the optical axis there.
Could cause, if you've got it going in a pattern and light comes out in a cone, you could cause some noise surrounding whatever's actually in the direct center of it, depending on the angle of the lights internally.
Yep, so if you want to be straight on, and that's it. So if the lighting may cause some kind of artifact to show up on the object. So if we have a very specular surface that's going to give us that light, like we showed here, where we're going to have that specular light that's going to come directly back to that camera if we're aiming down at that surface. And so if we have a surface that's very mirrored, we're going to be blinded by that light coming back, and it's going to be coming directly back into the sensor. Then we have dark field. From the basic eye there, that could look like the exact same type of light. Typically though, you can see here, they're wider. Because what we want to do is we want to get that light out on the outside, and we can do a whole other class on just lighting, but on the outside of the W of lighting. Meaning we're looking at dark field, so we're looking at the exact opposite type of light. We're looking at that diffuse light with no direct light. And we want it to really look, as you can see in that picture up there, from the sides. What do we think that might give us by coming at a low angle like that, as opposed to coming from the top down? Carly, you got this one before. Let's go with, what do you got? Anything you might see with a dark field light, even based on that image, that you might not see with a ring light or something top down?
You might not get the contrast that you need.
So you might not get contrast. Do you know what might cause that? Or you might get good contrast, but anything, it's going to be surface roughness is really what you're going to look at. You're going to see more of the shape of an object than you are what's on the object. So what's actually printed or encoded from colors and lights. You're going to see edges significantly more than you're going to see what the actual object itself is. So depending on how you mark something, that could be a huge advantage, or that could be a huge detractor on your capability of reading.
So if you're engraving metal, the dark field might be...
Yep.
Okay.
Absolutely, yeah. Engraving, especially if it's, it comes down to kind of how the engraving works. So, and what the metal surface is as well. So, if you're engraving, you could be polishing a code actually on a, etched surface. And that, from a dark field, is going to be great. You'll actually see from dark field, the light's going to come in from the sides. It's going to reflect away from the polished surface. And it's going to be very, the diffuse light is going to scatter on the rough surface. So that's how with dark field light, you can see those rough surfaces very well and not see the smooth surfaces at all. So absolutely. And then you can do the reverse on objects also. Next, we have dome light. And you can see here with dome light, we're not shining light directly down. I know it's a little bit lower, but you can see a big dome like this. We're shining light up. That light's hitting a diffuse surface and then coming back down on our object. So in photography, this would be a light box. That's what you would be thinking of. So when you see those perfectly uniform, nice images where light is even around all sides, that's a dome light. So one of the tough things though on the dome light is, let's say, you see right here for the dome light, you're almost right, and that's honestly even a bad picture right there. You're basically on top of the part. If you look over here, I'm over top of the part completely. What would happen with a dome light if you lifted it up a little bit higher? What would it turn into?
A ring light?
It would turn into a ring light. Because the second you get out of the dome, the light's coming from a single spot, and now you're going to be looking at diffuse reflect, or you're going to be looking at that speculative reflection as opposed to seeing this, even light. And this is the difference. I mean, for anybody do we have any photographers in the group here? Anybody done any personal photography or even a point-and-shoot camera or anything?
Yeah, I guess.
So if you're doing that, the idea of a nice cloudy day but sunny is like the best way that you can have photography, because the clouds are going to diffuse that light much like a dome here, and you're going to get this even no shadow. Not going to pick up any like nose lines or creases or anything like that, which for professional photography is exactly what you're trying to get away from. And you'll have this nice, evenly smooth image. And then finally, we have something called dole lights. So this is on-axis lighting. So you can see we're actually using a prism here to give us the benefits of a dome light without having to be a full dome light. In this case, the light's actually fully on-axis. So the ring light, which would be kind of the lower cost version of a dole light, we just put those LEDs around about where the optical axis is. They're going to be a little bit bright, they're going to be a little bit intense. Here we get a very, very even backlight, put it across a prism so that we can look down from the camera straight through the same axis that the light's coming. So the light reflects off that surface, the camera looks through it, the light's able to come back up this side directly through the prism. And that's ultimately how it's how a prism works in general, but that's how that prism works. And so we can get very, very even illumination on something that has print or a slightly uneven surface. So we don't see those differences, and we only see the actual color difference. What our eyes typically see when we're just looking at the even sight. So talking about the laser marking of a product, which is typically one of the harder things to look at or mark. Using things like dome and dole lights, we can, if we're encoding actual contrast into the code, meaning it's not just a surface difference, but we're actually making, like burning and changing the chemical composition of the top edge, top layer, and depositing some kind of dark or light material on a etched metal surface. Something like the dole or dome light on this bottom side of the illumination is going to take away all those curves and edges and the striations in the metal and leave it so all we see is the actual marked part of the code. But in the same note, if you were to take a code and not change the actual color of the code and just do what you were talking about before and change what the surface roughness is, almost scratch the code into the surface, our dome light is done. We won't see anything. And then depending on how it's scratched, the dole light may give you some reflections. I don't have a slide about it, but has anybody ever heard of dot peen codes? Yeah, decent amount. So lots of head nods. What we're doing with the dot peen code is we're taking some kind of tip and just smashing a hole, an indent into the object. The reason this works very well when we're reading is we're basically making, I don't have a whiteboard or anything, but we're making a V in the bottom of the object. So if we think of the differences between a dome and a dole light here, if we have a perfectly V'd surface and we shine light as a dome, what's going to happen to that surface? Because it's coming from all angles.
No difference in contrast.
It's going to disappear. You won't see anything because you're going to have the same amount of light coming in every angle, and so anything that's going to bounce up to the camera is going to have a hard time coming back and being seen. So now if we look at a dull light, it's all coming on a very specific angle. So if we look at how the dull light's going to work, the light's going to come down into that V, and it's going to reflect off at opposite angles. So it's not going to come back up to the sensor. You may get a little bit of a spot at the bottom where it hits, and comes up. But typically it's going to hit and go off, and hit and go off, and then the other surfaces that are flat are going to come straight back up to the sensor. So now you're going to actually use that use that angle to detect. And you want that harsh V in a dot peen in most applications in order to create that type of mark. And then if you think about what happens with a lot of dot peens, the reason they're done is because you're going to put coatings over them. So now we might need to rethink what the right way to do that. If we had a V, and then the coating came in and filled it so it's more like a low pool, now that idea of using the direct reflections to go off in either way is out the window, because now we have a gradual curve. So now we have to look at the other types of lighting like dark field in order to handle that curve of the surface and not see that light. So you can see even the same code, depending where you are in the process and how you create the process, is going to change how you want to read that code. So any questions on just the basics of lighting on a code? And we'll go over examples of each of these types after a little bit there.